Society members, I'm Casey Dreyer. I'm the Chief of Space Policy here at the Planetary Society. Happy to be using our brand new community to speak with you today to answer your questions about the newly released NASA budget for fiscal year 2024. I want to mention two pieces of web content on planetary.org that will be germane to this conversation. One is our official press statement that came out a few days ago. You can find this in our press room, giving the official Planetary Society reaction to the budget. We highlight overall positivity and call out a few areas that we think need some work. In addition, just today, I published a new article going through the budget in more detail, providing specific analyses on both human spaceflight and planetary exploration. So I can talk about both of those, but otherwise I'll go through the NASA budget in broad strokes. Even though, as some people will point out, this is just a budget request. This is a starting point for discussion. At the end of the day, though, because you can only spend $1 once, and even when you're proposing to spend money, you can only propose to spend money once. That where you see the money flow, where you see it grow, where you see it shrink, that shows you at the end of the day the true priorities of an administration, of a Congress, of a nation, because you are forced at a certain point to choose where you put limited resources. And so looking at budgets and looking at where they propose or ultimately spend money tells you something about the overall direction and goals of a nation's space program, and differentiates and allows you to suss through what is just pure rhetoric and what is a true commitment. So this is what is really ultimately enlightening about budgets. This is something I want to keep highlight here to begin this discussion, which is NASA's overall budget adjusted for inflation over its entire timeline. This is a resource that we provide here at the Planetary Society, which is NASA's historical budget data set. This is a relatively detailed, kind of wonky, for those wonky among you who want to have access to this, we provide an opportunity to read through and list and compare NASA's budgets from today all the way back to its inception in 1958. Going forward, we are find an opportunity here to compare overall spending adjusted for inflation, right? So $1 today is, we equalize it to $1 yesterday. The solid line here is what Congress has actually given, and the dotted line is what the president has always requested. Now, even though we talk a lot about the classic phrase that the president proposes and Congress disposes, but that's not necessarily true for organizations like NASA. And this is something that I've done some research on that is not easily digestible here, but in terms of spending correlations, most of the time when the president proposes an increase, Congress will provide an increase. And most of the time that the president proposes a decrease, Congress will decrease the budget. So I have a correlation right here historically of 85%. That is, I think, really important to remember at the end of the day, when we're comparing and the value again of analyzing a president's budget request, it sets the fundamental conditions for the future debate that will happen in Congress. And most of the time, in a large sense, they kind of get what they want to various degrees. The other important thing from this graph that some of you may be very familiar with is, of course, this big peak here in the 1960s. Obviously, we all know what that is. That is Apollo. That is the one successful example that we've had in human history of sending humans to the moon and back. And it puts it, I think, in a scale that's relatively important to, keep in context here, that NASA peaked at roughly, in today's dollars, even post-inflation, roughly $60 billion a year to really execute that goal. And then rapidly dropped off for reasons that we can go into on a separate long-term discussion in terms of space policy. But interesting point here, this spike, for those of you detail-oriented folks, is the one-year special appropriation for building the Endeavour space shuttle after the Challenger disaster. And then we have a growth in the 90s that has been followed by a slow decline, basically flattening out at roughly $20 billion a year for the last few decades. You'll see that I think this is really important, that we've had a constant functional increase to NASA's budget almost for the last 15 years. Inflation really took a bite out of NASA's budget a few years ago. The proposal, what we have this year, is $27.2 billion. And if you adjust for inflation, that is roughly equal to what NASA got in 1996. So this would, this is a solid budget that we have a modest increase of 7% from the year before. And that increase catches us up to where NASA was again in the mid 1990s. That really I think, illustrates why, when we say why NASA hasn't done X or Y or Z in the last 20 years, because it's really been squeezed at this $20 billion level to do human spaceflight, robotic spaceflight, earth science, heliophysics, aeronautics, all the things that NASA's asked to do. And this recent growth over the last 10 years has really opened up the option space. This is why we're able to pursue Artemis and continue doing Mars sample return and do the James Webb Space Telescope. So it's one of those broad growth opportunities that everyone has won. This is not a situation that will last forever. And I think this is what the big challenge is. This is what the challenge is this year is, can we continue growth at all? Or are we even facing a declining budget situation? And if that happens, all the great proposals and ideas in the world won't help you if you just don't have the funds to execute the programs that NASA is being tasked to do. Artemis is going forward at this, in a sense, an experimental program. Can you do a bigger than Apollo return at a fraction of the Apollo cost? The big X factor there that we have now that we didn't have at any point prior to this is a very enabled and functional and capable private sector that is providing huge cost savings, particularly in landing with the human landing system. And we also have a broader international coalition taking us to Artemis, participating in Artemis, that gives a certain level of international relations and political stability because it's a geopolitical goal now for the United States, that we want to work and strengthen partnerships with allies and like-minded nations. And you do that by doing this grand peaceful endeavor together. The other big aspect of this is the overall growth in science. And we've seen this growth in science happening now for about the last 10 years as well. Going down to the science, we're looking at an $8.3 billion request for science. That's a 6% increase. And again, this roughly matches the rate of inflation. So you can almost consider this flat in a functional level. Main increases go to earth science, some to planetary science, everything but heliophysics, unfortunately. Biological and physical science, that's microgravity research done on the ISS. That was recently moved into the science division from the ISS accounts just a few years ago. Planetary science, of course, is what we are here for. This is why I work at the Planetary Society. It's what got me into space advocacy, was wanting to see missions to Mars. And that has been on this extraordinary run in the last 10 years here at that we've seen at NASA. And this is a full historical trend of planetary science spending. This is the budget line that pays for all robotic planetary missions that don't go to don't go to Earth, even though it's a planet, and don't orbit the sun. This is what we classically think of is in terms of planetary exploration. This budget line is at a current high, historically speaking. It's not necessarily, it's roughly in line with these two peaks in the 1960s, which has coincided with lunar exploration during Apollo era. And this interesting peak, which I'm always fascinated by, is the peak to pursue the Viking landing missions in the 1970s, which currently, but maybe for not much longer, represent the largest expenditures for planetary science robotic missions in history. They were roughly a $7 billion mission. They did build 5 flight-ready spacecraft, 3 landers. One is a flight spare that is us, currently in the Smithsonian Institution Air and Space Museum in Washington, D.C., and 2 orbiters. That did not last. It was a spike, and planetary science has been struggling to grow for the last 30 years, and really had this nadir here in the last, in the late 2000s, early 2010s that we've been crawling out of. And this increase has been one of the most important developments in space exploration in the Planetary Society's history, because it's enabled the simultaneous execution of a Mars sample return campaign, starting with the Perseverance rover, and a flagship mission to Europa to really characterize and understand the ice barrier and ocean underneath that. Some of the most exciting missions ever in planetary science are coming our way in the next few years because of this growth. And our job, I consider, at the Planetary Society is to maintain this squiggly line, at least at this level, and hopefully higher, because there's a lot of great missions that are coming down the pike. Now, if you're looking at a narrative for this budget, and this is the difficulty of trying to draw a narrative out of a roughly 1,000 page document that has a number of competing areas of interest and political needs and various other aspects. The narrative to me is that, and I always, I like eating, so I tend to go for a food metaphor, but I call this a meat and potatoes budget, where it does exactly what it needs to do, but not that much more. And at the end of the day, that's fine, because NASA has so much on its plate with going back to the moon, with trying to pursue a number of flagship science missions, that it doesn't need a fundamental restructuring and rethinking. I think we're on a very positive trajectory. And if we have a nice filling meal here of a nice 7% growth increase to keep things steady as she goes, we're overall in a very good spot. Of course, there's a couple of fundamental problems that we do need to address. These aren't minor necessarily, but they're specific, and there's not a whole host of them. The biggest loser, in a sense, of this budget cycle is the Veritas mission. Just 2 years ago, right, not long after the claim of the phosphine detection in Venus's atmosphere, which is a potential biosignature. It has since been significantly disputed, but was kind of the kickoff for this reevaluation of why haven't we been back to Venus in a number of years. As a result of that, NASA selected and went through a very competitive process called a discovery competitive selection for what discovery missions are lower cost, competed. So you have a science team propose these to NASA, and then they have to justify it. It's the survivor, in a sense, of planetary missions. And NASA in 2021 selected 2 missions to go to Venus. This was the biggest change in fortunes for the Venus community in decades. The last mission to go to Venus was Magellan, which launched in 1989 and ended in 1994. The US mission, I should say. There's a number of European and Japanese missions that have been to Venus since, but nothing with the kind of big, beefy radar that you need to study the surface and really understand the geomorphology of this planet. Veritas was going to be this. This is Magellan 2.0. It's a much improved mission. It had been chugging along just fine. And then, very suddenly, late last year, the team was directed to stand down. NASA removed all of their extended funding, development funding, and functionally laid off the entire engineering and science team. This is bad. This is a bad place for a mission to be in. It's not explicitly canceled, but I would characterize this as a soft cancellation. Again, it's a scientifically important mission. It's endorsed. There's no one is debating that this is not an important mission. The problem is that NASA seemed to have run out of money, and it had to come from somewhere. And this was identified probably as the politically weakest mission to pick off, because it's at JPL, and JPL has 5 other larger missions. And this is going to be one of the main areas of focus for the Planetary Society in how we pursue advocacy this year. And you can expect some more detail on this coming from us soon. Opportunities to communicate with your member of Congress, to raise awareness about this, and to really make a good case about why we should, A, set a new launch date for this mission. We propose 2029, which is a very reasonable 2-year delay that allows the mission to get back up on its feet. And then find a funding profile that allows that. So Veritas is a big problem here. And the other, and I wouldn't necessarily characterize this as a problem, is Mars Sample Return. And Mars Sample Return is a big, beefy mission. It is going to be the largest planetary mission of basically since Viking. It's already tracking to be a $5 billion mission. It got $822 million last year. That number itself is larger than NASA's entire heliophysics division. And Mars Sample Return is requesting $950 million this year. And NASA itself said costs are likely to rise, and it will need probably north of $1 billion in coming years. That is a big ask. And the consequences, though, because it has to operate on a Mars launch window opportunity of every 26 months, if it doesn't launch as planned in 2028, if it misses that launch window, you have to carry this huge standing army of workforce for another 2 years. You're probably talking about billions of extra dollars if it misses that launch window. That has serious downstream consequences for a lot of other planetary missions. And so the cost growth is a concern. This is a complex mission that is unprecedented. So this is the types of mission we want NASA to do. And the best way, in a sense, to preserve future missions from, in a sense, enduring the consequences of a missed launch window is to give Mars Sample Return the funding it needs now, early on in its development period, as much as possible, so problems can be worked out. They have the engineering talent that they need. They have the resources that they need in order to meet this launch window. And that's going to be another big concern for the Planetary Society. So I'm going to start taking some questions. So the first one I see here, are there any concerns that with Space Force's budget, lawmakers may feel like space is double dipping or be feeling space fatigue and is less inclined to fund NASA? That's an excellent question and a nice way to frame it. For context, Space Force, which is part of the Department of Defense, that's the newest branch of the armed services, created just a few years ago, now officially this year has outpaced NASA in terms of its budget request. They're requesting, I think, approximately $33 billion for Space Force. And Space Force doesn't launch people into space. So this is all functionally robotic stuff. This is a big increases. I think not. And that's because Congress politically approaches the two pots of money very distinctly here. And what they call, they're both considered what they call discretionary spending, which is that Congress has the discretion every single year to modify spending for these types of programs. The other type of spending is called mandatory. That's stuff that's already written into law that basically funds and expends itself, things like Social Security, Medicaid, servicing the federal debt, and so forth. All that happens automatically. Discretionary spending, what we go through every year to get Congress to fund, is functionally split in two. The Department of Defense is half of it, and the rest of government is the other half, including NASA. Of that discretionary amount, as I'd say this year's maybe they're asking $1.8 trillion to cover both of those. NASA accounts for 2% or something like that off the top of my head. So the Space Force account, because it's inside this DoD defense discretionary, is almost a completely separate entity, completely different politics. And generally in the past 5 years, Congress can't help but spend more and more. The increase they gave to the Department of Defense last year was twice the size of NASA's entire budget. So I don't think there's any necessary competition. And I think generally they're seen as significantly distinct. There's a few joint projects in planetary defense. NASA will use some of the sensors that Space Force has for detecting space debris in the infrared. And also there's a joint project now for nuclear thermal propulsion, where NASA and DARPA are looking at a joint demonstration mission. But those are very specific projects. Next question. What impact has the use of SpaceX launch systems had on the budget for NASA? Is the use of private launch systems funded from this budget, or is that a separate funding stream? Another great question. Yes, SpaceX has saved NASA a ton of money. NASA openly and freely admits it and happily admits it. We saw this very recently with the Europa Clipper, which was looking for a launch vehicle. They had bookmarked or earmarked, I'd say. They were expecting to spend about $500 million to launch Europa Clipper. NASA selected SpaceX's Falcon Heavy, and as a consequence, they're only spending $200 million. So it's a savings of nearly $300 million to NASA to launch on a Falcon Heavy. Before that, it would have been probably a Delta IV Heavy, and that's what the $500 million was for, or even an SLS, which is north of $1 billion for a single launch. And so, yes, NASA has absolutely. Thomas Zurbuchen, the recently departed associate administrator for the Science Mission Directorate, has openly stated this too, that NASA has saved a lot of money on launch, mainly because of SpaceX's Falcon rocket. And we hope to see similar savings coming from Blue Origin's New Glenn and future rockets coming online. Plus, there's a number of very small launchers like Rocket Lab's Electron that is launching or did launch the Capstone rocket mission to the moon for, I think, $15 million or something like that. And so, yes, they've been saving a ton of money on private launchers. And they've been able to, and actually track this in my planetary exploration budget data set. This is the cost of launch vehicles adjusted for inflation over time. And it's a bit of a messy, this is for my own edification, I haven't published this. But you can see early on in the 1960s and 70s, you were spending around $100 million a launch, depending on your launch vehicle. Cassini was this crazy outlier because it was a Titan III, I believe. A single time launch on it's like one of the last big Air Force rockets that launched Cassini. Same with Mars Observer. But you can see for a long time in the late 90s, early 2000s, this is the Delta II rocket series. Very, very affordable. Probably talking $80, $90 million a launch for those. you started seeing this steady increase of costs for planetary missions, as it was basically the Atlas V was your only launch vehicle, going into north of $150-200 million a launch. And then now trending back down, Lucy, Psyche, DART, these are all SpaceX launches. Perseverance was on an Atlas V, which is also, because it was carrying nuclear plutonium-238, a nuclear material, extra expensive to launch on those. So yeah, so I mean, you can see this clear trend of decreasing costs thanks to SpaceX, and this is across the board. So absolutely, we've seen huge savings from that. One of the best investments NASA's ever done, and also equivalent savings on the human spaceflight side. NASA in this budget actually listed out the total amount it has spent on commercial providers for launch in the last 20 years, and it's $26 billion. It's like, wow, that's a lot of money. But that's actually, for as many times as they've launched, a really good deal, considering what they used to pay for the shuttle. Operating the shuttle was approximately $5-6 billion a year for, at the end, 3 to 4 launches a year. So yeah, absolutely big improvements on this. Okay, next question. If Artemis leads to a permanent manned lunar base, won't that result in a significant budget increase for robotic and manned missions? Potentially. And I think we've seen this a little bit. So I think maybe another way to rephrase this question is, does a human initiative to the moon, does that help the robotic side? So far, the answer has been yes. And the biggest development we've seen in this has been the establishment of the LDEP, the Lunar Discovery and Exploration Program, in the Planetary Science Division budget. And that has grown from $0 in 2018 to $500 million a year in 2022. And that is what does the Commercial Lunar Payload Delivery Services contracts, this new attempt to provide a rapid and delivery service, FedEx-like delivery service for scientific payloads to the surface of the moon. It funds the upcoming Viper lunar rover that's going to look for volatile things like ice and other things like that. It also funds a bunch of lunar orbiting small sats. And so all of these lunar scientific things are happening at the order of $500 million a year because of Artemis. That would not have happened without Artemis happening. In terms of having a lunar base, probably, in the sense that once you're at the moon, you can justify a lot of lunar science. And actually, something, again, an interesting little bonus in this fiscal year budget, the 2024 budget, is within this LDEP, within the Lunar Discovery Exploration Program budget, there's a new account line for Artemis surface science. Right, this is developing the actual instruments the astronauts will use on the surface of the moon. This is very similar to the ALSEP, Apollo Science lunar science packages experiments that NASA developed. So this is a big step, and I think there's huge opportunity there. The question is, will it benefit or will it hold back and kind of consume the budget from, going to outer planets or Venus or Mercury, places where astronauts won't be going anytime soon? And so far, we haven't had that to make that trade-off. And that's because we've been in an overall up and to the right budget situation in terms of funding. And so that's an open question. So far, we've made out pretty well. Next question. Of the 2 Venus missions, why was it Veritas that lost funding? That's an excellent question. So there are 2 Venus missions, right? The other one is Da Vinci. I forget the belabored acronym that stands for, but it's an atmospheric probe that's going to, actually super excited to see this. They're going to orbit Venus twice and then drop its probe down. It'll take hundreds of pictures on the way down, measure the atmosphere, and then plop down on the surface and try to live as long as it can. Da Vinci is being made out of Goddard Space Flight Center in Maryland. Probably is a big factor of why it's fine versus the 5th JPL mission. One of the explicit reasons given for the delay, indefinite delay of Veritas, is a problem that's happened with JPL and its workforce, identified by the delay of the Psyche mission. This is the asteroid, the metallic asteroid mission that was supposed to launch last year. And NASA didn't make the launch date, not because of some big exogenous event, but because, in a sense, management screwed up. There are some serious management issues due to COVID, primarily, and the fact of trying to make a robotic spacecraft in a partial remote working environment. There's also identified in this independent review that came out about this that JPL's workforce is stretched really thin because they're trying to do Europa Clipper, Mars Sample Return, Perseverance. NISAR, which is a big Earth science mission, NEO Surveyor. They have a lot on their plate. NASA, the stepping back, NASA's actually put themselves in an interesting position here, in that one of the problems is at places like JPL is that they're now competing for the best talent of the engineering talent with this new commercial space sector that didn't exist 10 years ago. And developing a commercial space sector was a stated goal of NASA and still is. You want to create a competitive commercial space sector, but by doing so, they've created a competitor for themselves, for their best people. And so some of the best people getting plucked out of NASA centers that, who don't want to work at a big government bureaucracy, or can get paid a lot more, or can get equity in a company, right? Lure them away with all these opportunities and rapidity and, that exciting businessy venture capitalist stuff. It makes it difficult to compete for the best people. And so JPL is getting hit really hard with that. Also, Los Angeles is an expensive place to live. It's a concentrated aerospace sector, so there's a lot of competition. I mean, SpaceX is just down the road, not to mention a handful of other companies. And so they're really were struggling to manage this. And that was notably one of the reasons why Veritas was delayed. It's like JPL can't handle this. Now, I should note that this characterization is disputed by the Veritas team that says that primarily the spacecraft is being built by Lockheed in Boulder, Colorado. But that was one of the given reasons. And so I think that and then, so the other thing is JPL has 5 of the missions that are much larger. And, if they have to go to the bat for a mission, it's not going to be for a low-cost Venus orbiter. It's going to be for this $5 billion Mars sample return mission. And so when pressed, that's what they're going to defend. And so I think that's why I said was probably seen as the easiest thing to pick off versus Goddard, that doesn't have a ton of planetary missions, probably really holding on tightly to their Da Vinci mission. So it's no one's fault on the team at the end of the day. It's really a function of just happenstance. If anyone's read Alan Stern's book on New Horizons, the mission to Pluto, he talks about very carefully and consciously committing his mission to the Advanced Physics Lab in APL and also in Maryland, run by Johns Hopkins, versus JPL in California. Because when he said to JPL, is this Pluto mission, is this going to be your top priority? They said, no, our Mars stuff is our top priority. And when he went to APL, they said, yes, Pluto will be our top priority. And that saved the Pluto mission when it was attempted to be canceled multiple times, which the Planetary Society helped work with back in the early 2000s. It saved that mission being that priority of that center. So this is the type of stuff that comes into play that's not, it can be frustrating sometimes, but is in a sense the real politic of building a spacecraft. Let's see, I got a couple other questions here. Would Veritas necessarily have had a better chance if it originated from another NASA center? Yes, I believe I just addressed that. Does NASA try to reuse to save money? For example, a basic platform for spacecraft which can be used for different missions by adding different instruments. That has been studied a number of times. Notably, there was Cassini was, I'm trying to remember what it was exactly called. It was like a Mark II spacecraft design that was intended to be used for a comet flyby and for Cassini to Saturn. And the problem is when you're doing mission design for scientific purposes, this is different if you have a more practical purpose, but for science purposes, you are building and ornamenting your spacecraft with these exquisite, bespoke, sensitive instrumentation that will detect electrical noise from the wrong type of instrument placed nearby, or need to work at a perfect temperature itself, or need to sit on this long boom in order to get away from the induced magnetic or electrical fields from a spacecraft in order to detect the data you need from the place you're going. And those places you're going in planetary science can vary considerably. If you're going to Saturn, the amount of solar power you're going to get is a fraction of what you would get if you were going to Venus or Mercury. And if you're going to Venus or Mercury, the amount of thermal protection that you need is way more than you would need if you're going to Mars or Saturn or Jupiter. And so the wildly varying conditions in which you need to operate make it really hard to have one common spacecraft bus. This doesn't have the same problem if you're just ever in Earth orbit, or you're doing a commercial satellite system or communication system, because you're going to be building the same thing many, many times to operate in the same environment for the same purpose. So far, we really haven't had that for planetary science because of all the particular needs of scientist. And if you're going to constantly push the boundaries of what you're trying to understand and detect, you're rarely going to be doing the same thing twice. As close as you've come to this was a mission called MMS. I'm forgetting the exact definition of MMS, but it was a heliophysics mission where they made 4 equivalent spacecraft to all orbit the Earth at the same time to help map out the 3-dimensional structure of Earth's magnetic field. And even then, the way that they're doing this is not out of a production line. It's still only 4 of something. That you're not really increasing that. And this is one of the limitations, I think, when you look at in terms of what can commercial providers bring to certain aspects of space to lower costs. Rockets like the Falcon 9, you're building the same Falcon 9 every time. You're building the same crew vehicle. You're building the same Starlink communications satellite over and over again. And so you can get economies of scale that way. But you can't do that with these really one-off unique systems. You're designing and building them by hand, and you just don't get those economies of scale. And that's where I think you can really lean into the strengths where commercial can really help, is if you're building a lot of something, like, again, rockets or crew vehicles versus one-off missions. Are there any imminent dangers to specific missions if the debt ceiling is not resolved in time or blows up and is resolved in still a few days, but still blows up? So the debt ceiling is, very quick base level recap. The government has already appropriated money by Congress, by law, that they have the authority to spend money. But a separate law governs the government's ability to borrow money. And this is what happens because we spend more than we take in. So we have to borrow. There's a statutory debt limit ceiling that Congress needs to occasionally increase in order to fund the things we've already committed to. It's like saying you've put things on your credit card and you have to make sure you can pay what you owe on the credit card. If we breach that, that's a kind of a big, broader discussion that has significant consequences for the broader global economy. And by the Constitution says that, we can't abrogate our full faith and credit of the US government. So there's a lot of tricky issues there about whether it can actually happen or what authority controls that. But until then, it's just, we don't want to mess with it. We just keep raising the debt ceiling to pay what we owe, because it's basically things like bonds and treasury bonds we have to pay interest on those. And if we can't pay interest on those, we've broken our commitment to pay the debt. And then suddenly we have no faith and credit in the US system, and so forth and so on. Lots of bad things happen economically. If NASA can't pay, then they can't pay. And you start having accruals add up. It gets very complicated very fast. It's unprecedented, so it's hard to look into history to say what would happen. It wouldn't be great. NASA would probably be relatively low on the consequences of this for the global economy. The more practical worries that I have is whether the government shuts down. That's a slightly different situation when the government no longer has authority to spend money as the federal government up to a certain point. And so things like NASA, they just like, all right, we can't pay you these contracts we promised. We're going to hold off, and government employees can't go to work, and that slows things down. And we nearly missed a launch window in 2013 with MAVEN, the mission to Mars, when we did have a government shutdown. But there are ways to work around it. MAVEN was declared, you can't shut down government things if life or property is put in danger as a consequence. MAVEN, because it was a communications relay for ground-based missions like Curiosity at the time, it was declared, it would damage the property on Mars if we couldn't communicate with it. So there are ways to get around that, but debt ceiling is a very different situation, and hopefully we don't have to figure out what happens there. Let's see. Would future international partnerships with other countries around the world influence NASA's budget in any way? Can working together with other countries reduce the overall mission costs? A couple ways to think about this question. There is a trade-off you make when you have international collaborations. And the trade-off is, in a sense, you're exchanging complexity for political stability, if that makes sense. In that you're suddenly interfacing with a completely different space program, bureaucratic structure, engineers, probably a language barrier. In some ways that can help save you money. A great example, ESA, European Space Agency, has been increasingly engaging and having very tight integrations with NASA projects. Artemis, the service module on Orion, is made by the European Space Agency. Orion cannot function without that service module. And the European Space Agency paid for that and gave it to NASA, but as part of a barter agreement, basically, as opposed to paying direct cash for the International Space Station operations, they paid their version of that barter by providing Artemis hardware. And you've seen this with Mars Sample Return, where Europe is going to provide at least, I think, over 2 billion euros to build the Earth Sample Return solar electric powered spacecraft that will go to Mars and then come back with the samples. In aggregate, that probably saves you some money, but then the complexity by interfacing with those other space agencies and working on, various schedules and uncertainties probably comes out as a wash, I would guess. I don't think anyone's done a real solid study on this. A good example of how this can work negatively for you is the InSight Mars lander mission, where all of its instrumentation, or two of its major instruments, were provided by France and Germany. The French space agency was unable to provide the instrument in time, and it made the mission miss its launch window. And so even though it saved money by not making its instruments itself, NASA ultimately had to pay $180 million to endure that 2-year launch delay for InSight. And so it's debatable whether it ended up saving money in the long run. And they just didn't have control over that. But what you get out of it is political stability. And I think at the end of the day, that's probably what we're all more concerned about is, can these projects endure downturns, economic downturns? Can they endure changing political parties or changing political ideas? How do you build in on an annual, when you have to fund your project every year, how do you build in stability for a project that will go 30 years? International Space Station, once it survived its close votes in the 1990s, its existence has never been in question. And one of the reasons is that U.S. has high-level multilateral agreements with other nations to run the space station. And to end the space station, and we've even seen this with Russia trying to pull out, that it would abrogate at such a high-level multinational treaty that it's almost impossible to do so. Artemis is designed explicitly to bring in a broad international community in order to build this stability. The other interesting thing about Artemis, to touch on the latter point of that question, is how do you get other space agencies at different levels or costs to participate? And I think one of the reasons the moon has been so fertile as a project in order to have other nations participate is that you do have various levels of commitment that are relatively straightforward. You have the Artemis Accords, which is basically any nation can raise their hand and say, I agree. And it costs them zero money to do so. So I agree to these kind of philosophies about exploring the moon and respecting each other's and promoting science and respecting these careful places on the moon. It's a way for people to demonstrate commitment without having to spend billions of dollars. And then with CLPS, you have these smaller delivery services. Maybe you can spend $10 million or $1 million on special instrumentation. Or if you want to, like Canada, add an arm to the Gateway Space Station. Or if you want to be like European Space Agency and build parts of the Gateway Space Station, you'll get seats and launches out there, or Canadian or the Japanese Space Agency as well. You'll start having access to the surface of the moon. The bigger your contributions are, the more participation you have. And so I think it allows careful structure and thought, which has definitely gone into this with Artemis in particular, allows this. The more shots on goal you have, the more opportunities you have to do something, helps give lots of opportunities for various people to participate. International Space Station, with having private astronaut flights coming up now, has actually been able to increase access to the United Arab Emirates. Really interesting. Their first 6-month-long astronaut stay is happening right now, not because of a formal NASA agreement, but because Axiom bartered a seat on the commercial crew vehicle for their United Arab astronaut to participate in this long 6-month stay on the station. And so the more kind of innovative opportunities we have, I think the broader you can have participation at different levels of that. Okay, I think I'm being told we're good. As you all know, if anyone who's listened to the podcast, I can go on for probably literally hours, but it's everyone's interest that I don't. And this has been an interesting experiment for me to take your questions, and always a delight. And thank you for being here. Really enjoyed speaking with you. Hope this has been valuable for you. If you do like listening to me go on and on, check out Planetary Radio Space Policy Edition, which is at planetary.org/radio. Every month I'll have a new episode talking about some aspect of planetary or space science, history, politics, and policy. Monthly newsletter, The Space Advocate, is at planetary.org/space advocate. And of course, you can find me here on the member community, frequently posting in the space policy and budgets section. So thank you. And thank you to my colleagues for making this all happen. And we will be in touch to talk about all the exciting things happening in space in the next 10 years. Thank you and take care. Ad Astra.